Hello everyone, I am Ria, one of the co-organizer and the Women Techmaker Ambassador of Kolkata. I hope everyone is doing safe and great. Welcome to Android 11 series by GDG and WTM Kolkata. Android has evolved beautifully over a decade with 2.5 billion devices and making people's lives better. Android 11 series will be hosted for upcoming 4 weekends starting from today. To begin with, we have India's first developer advocate for Android from Google, Mr. Amrit Sanjeev, joining us today to talk about Android 11 features and more. Also, queries will be addressed right after the Amrit session. Over to you, Amrit.
Thanks, Ria. Hi, everyone. Hope everybody is taking the precautions and being safe. If we can have the slides up, that'd be great.
Yes. Thank you, Amrit.
Cool. So in this session, we'll run through the top features in Android 11. I would want to clearly say that this is not going to be an exhaustive list of features. This is just going to be a set of things that I feel are important for developers who already have apps on the Play Store and really want to kind of get their apps working well on Android 11 too. So look at it more like a set of pointers on features and what you might need to take care of when you actually build a application that needs to run on Android 11 too. So I will most probably deal with all the changes that are happening and less towards the new features, completely new features as such. There is a section where I'm dealing with the new features, but that is not the highlight of the session. I'm going to spend more time towards things that you might need to change in order to make sure that your apps don't have any issues when running on Android 11. So yeah, this is my day job. I work as a developer advocate at Google. I manage the partner DevRel team working with top partners for India. And day-to-day work is all in the technical line. It's more on, and lately we've been focusing mostly on Android. So it works very well to my works very well to my strengths, and that is how the team is actually doing. We have onboarded one more developer advocate. She joined about 2 months back, and so we are expanding the team right now, and hopefully we'll have a bigger impact in the region. And as an agenda, like I said, focus areas going to be what are the new features in 11, overview of the top features, some of the privacy changes. I really want to highlight the privacy changes and call out a few of those things, and some of the new interesting features by which you could actually go ahead and build new experiences which are kind of novel to your users who might be on Android 11. So let's jump straight into it. Now, when we look at every version of Android, how we go about internally is that there are areas that are identified that this build would actually work and focus on. And in 11, a lot of things worked around performance, helpful innovation, product excellence. These were the highlight areas that we had actually looked at when we were the team was deciding the features for 11. There will always be a huge number of features that people want to do and a huge number of interesting features that are filed. But in the interest of time, as well as we have to prioritize with the resources that we have in hand and the schedules, we always have to prioritize. And so we usually take up areas like this and then kind of focus on features which are there. And that becomes the theme of the OS in that release. Now, with respect to timelines, we usually have 3 phases when we're releasing, and this has been happening, and most of you might already know about it. This has been happening for some time with Android, and this is how we've been releasing. We have a developer preview phase, which is basically an early build of the OS that is given to developers so that you guys can actually try things out on a developer preview on a device which is not a daily driver. We don't expect too many bugs, but then the whole idea is that is not for a daily usage device. This is more for developers to get an early preview of the direction of the OS. And the intention for doing this is twofold. One is that you get the OS way early, where you can plan and understand how the OS will behave and how your apps will behave in that environment. Secondly, you also can suggest features or give feedback on the existing features. The second part is really, really important. When it comes to regions like India, we have unique situations where the NBO markets are concerned. We have certain things which are very different in our region. It could be legal clauses here, it could be just the environment here, it could be the type of devices. So you would experience these problems, or you would experience these situations a lot more clearly, and it's commonsensical to you of how a new feature will work in such an environment than a team actually not located here. So we expect, the reason why we develop a preview is because we want to gather feedback from across the globe to understand that any feature that we are actually putting out there, or any restriction that we add to the OS, is not negatively impacting the developers in the ecosystem. So please use this time in every release, the developer preview time, try things out and share feedback with the team. Sharing feedback is, we might not be able to acknowledge every single feedback, but I can guarantee tell you that that feedback is taken very seriously. For example, in Android 10, scope storage was introduced, but halfway through developer preview, we got a lot of feedback saying that the restrictions that scope storage brings in order to mitigate that, developers needed a lot more time than just a couple of months. They had to think through these problems, and then that is how the team actually introduced a flag that could be turned on in manifest, which would automatically turn off scope storage and will make the system work as expected, for work as in Android 9 in 10. And that gave all the developers the ability to turn off scope storage for that particular build on Android 10, and then take the time till Android 11 to kind of understand how to work around that use case. So those sort of feedback do come in, and we take that seriously and we change it. During the beta phase, you would actually look at, the thing that you should do is, that is when you should strategize on the changes, the impact. By this time, by the beta, you should have already understood the impact of where your app might need work to work correctly on the build. Now in beta phase, the right thing to do would be to kind of create plans on how to change your application, where you need to introduce changes, and how to make those changes in order to get everything working as expected. Now, and before the final release, which is basically where the platform stability cycle runs, that's when your app should also kind of stabilize, ensure that the changes introduced does not break anything in the previous releases and things like that. So having a full spread, like through the year, having these changes being looked at and mitigated and built in a longer time frame allows developers to ensure that it's not a rushed job. You have enough time to think through the problems, enough time to understand how your use cases will differ, or how your use cases will get impacted by new changes, and then create the best possible user experience and migration to ensure that that new build, or that new OS, in that new OS also, your app runs, providing your users a great experience. Now, like I said, what you should do in a developer preview phase is basically go through the changes that are there. You should set up your environment, because during the developer preview, we also release the preview Android Studio builds, as well as the Android Pixel emulators. So you will be able to take the latest emulator and then test your apps against it. If you don't have a device that you can flash, you can always use the emulator to test your apps and run your regression tests on that emulator. You should also get used to the new tools and changes that are coming in, because sometimes we also bring in things that allow the application changes into tools that allow applications to take advantage of changes in the OS. So do that. But one thing I want to call out, in the developer preview phase, try avoiding making changes to the application. During the developer preview, it's best when you would actually figure out what changes are required and identify areas, primarily from the fact that because we get so much of feedback during this phase, there's a good chance that things will actually change a bit. The APIs are not finalized, so there might be a chance that you will need to rework if you try mitigating all the problems that you see in the first developer preview. By the time it reaches beta, you might have to go back again and then revisit some of this, purely from the fact that some of these APIs will change based on the feedback that we're getting. So you might want to just identify think through the solutions. And by the time beta is coming out, that's when the APIs are more or less stable, unless and until we find a really nasty bug that we definitely have to fix. We usually don't change many things in beta. We kind of only in terms of API contracts and behavior, we usually hardly change things there, and the intention is not to. So that would be a great time for you to kind of go ahead and make changes to your app. Even if you don't want to release it, it would be good to kind of gate it behind, say, remote configuration flags or things like that, the new workflows, but have them released in every sprint, have some work towards mitigating these situations in every release. And that way, it is not like that one large chunk going out, one large big chunk of change going out towards the end of the or towards the launch of the new OS. Rather, you are actually releasing smaller bits in every sprint, and that way your work can be spread across a time frame, stabilizing the code before the final release is out. So by the time the final release of the OS is out, your app would have actually got it tested and working and would be working really well on that version. So let's jump into privacy changes. Let's look at what changes have come into the OS. So if you would look at privacy changes, in Android 10, we introduced a lot of features that would help protect users' privacy. And we received a ton of feedback from users and the excellent feedback from app developers then. And one of the main focus in Android 11 was to build upon the successes of Android 10. And a lot of things is based on the feedback that we had given. In permissions, we made privacy and location changes to set location changes and top level settings. We made location permissions more granular and added background location reminders. There are a few things that we have done in order to ensure that the user's privacy is actually guarded at the OS level itself. Now, I've put a lot of things on the screen right now, but I'm going to talk through some of the important changes that we've done in this area. Now, let me start with scope storage. In scope storage, we introduced scope storage in Android 10, but we also gave this request legacy external storage flag, which allowed developers to kind of switch off the scope storage behavior for their apps in Android 10. Now, with Android 11, this flag has no impact on the behavior, which means scope storage rules are enforced by the OS in Android 11. And there are new things like API to do bulk operations. Read permissions are limited to media files. And if you look at scope storage as generally, just for those who haven't looked at this in detail, if you take storage as self in Android, the thing that you would notice is that you have two types of storage. One is basically your app's internal storage, and the other one is the external storage. Earlier in Android, if you actually wanted to access something in external storage, you would have to request the permission from the user. The moment the user gives permission to the app, what happens is the app has the ability to go and read all the files in the external storage. Yes, a legitimate app would just limit themselves to just the folders that it is creating. But we have seen many cases where this is getting misused, where people are scanning through the folders, people are looking through media files, people are apps doing various, sometimes misusing this additional ability to read through all the files. Because if you would look at it, there are multiple ways in which users' privacy can be kind of compromised, giving access to all the information, all the files that are there on the disk. Things like from media files, you could extract additional information from the media file metadata. Say basically having a certain folder on the external storage could be a good indicator that a particular app is installed on the device. It could be a competitor's app, and malicious apps go ahead to an extent where they can go and corrupt those files and make the competitor app not work well on the device. And those sort of activities, we definitely don't encourage, and we want to kind of let the OS not allow applications to do. So with scope storage, the change that is coming about is that if you look at the external storage, you have two types of files. You have media files, which are photos, audio files, video files. And then you have all the other files. So if you take these two categories, for anything that is these media files, there's a shared storage space, which is gated by a permission. So you have your media stores for photos, you have a media store for audio files, you have a media store for video files, and they're gated by permission. All the other files on the disk, if the app needs to access it, the user will have to use a system picker and pick the other file and give that app explicit permission to use that. Which means for all the files, unless and until and the user gives consent to access that file, the app cannot access it directly, access it programmatically. This means the user is always aware of what the app is actually trying to do. Suspicious activities like, say, an app trying to write into or read a folder which it did not create will come up clearly to the user. So the user can make the decision that, hey, this is not an access that I want to give, and then limit access to that. Again, we have added things like bulk operations. So you can go ahead and change a bunch of files, like edit a bunch of files or change the naming for a set of files. Those sort of things, bulk operations could be done. And this actually improves the experience. Assume you've created a programmatic, your app has an ability to remove multiple files. Now in the current system, before this bulk operation was introduced, for all the files that you select, for each of them you have to approve. The user has to approve to delete them. Now with bulk operations, the user can do one approval and then delete all of that. It'll pop up a dialog asking for one permission to delete X number of files, and that number and the files are actually listed out there, and it's very easy for the user to take an action on it. So a little better user experience comes with something like that. Now, when you give read access permission, it's only limited to media files now. Now, so the media store is like a common shared pool. Think of it like, let's take a camera example, where a photos app is there and a gallery app is there. Both are different apps. Now, photo is the app that is actually taking the data from the sensor and writing onto the disk. So any file that is created by the app, any file that is created by an app, it is accessible only to that app in scope storage. Now, if you want to share it to another app, what you could do is you can add it to the media store. Now, the photo is added to the media store, which means that the gallery app can now see the photo, because gallery app has got the permission to read all the photos on the device, photos in the media store. Now, if the camera decides not to add it to the media store, then the gallery app will not see it. So private data, which does not need to be shared, will not be added to these media stores. But there is a side effect of not adding to these stores, is that when the app is uninstalled, all the files associated with the app on the external directory is also removed completely, unless and until it is shared with the media store. So if the camera actually takes 10 photos and only 4 of them are actually added to your media store, at the end the user removes the camera app, then the additional 6 photos that it took, which it never shared, will also get deleted. So you have to take these things into consideration and ensure that your use case works as expected. There will be changes when you have third-party file pickers, because that will have to be replaced with system file pickers in most cases. So you have to look at all those changes, and more importantly, ensure that users don't get confused by this change. Guide them with correct prompts, guide them with a user flow which is intuitive, so that they don't really feel confused or feel that your app is unnecessarily complicated when working with files. So moving on, let's look at the special access type also. One other thing that we also know is that there are certain types of apps like file managers, backup and restore, antivirus, which needs a view of all the files in the file system. And that we understand there are legitimate apps which have use cases which require this, and it's not something that we can take away. In such cases, there's a new permission that is there by which the user can grant access to this, and but this is gated by a permission. Now, a Google policy will be there, which will check whether the app's primary responsibility requires it to have access to all the files. And if it is not, that app does not get that permission. So it's more like SMS permission that you have right now. This is guarded by a policy. So every app cannot add a file picker within it and then say, I need access to all the files and folders in the system. It has to be part of their legitimate use case. And there should be a real valid reason for that category of app to request for this permission. Now, coming back to permissions again, there's a new concept called, or rather, a new permission option called as one-time permission, uh, and this is when only the app is getting used. Now, the affected permissions here are location, access to mic, access to camera. Now, we see that in many cases of the apps, users give these permissions for one-time workflows. Say an app might require the camera access only for taking a profile picture of you, which you only use during sign up. After that, you never need a camera permission. So there are places where you don't want the app to have this permission throughout. Nearly all users don't go back to their settings and remove permissions for apps unless and until they're very most people don't do it unless they're very paranoid about the app. Usually people give permission and then they don't then they don't actually remove them. Now, with the new one-time permission model, you can actually give access to apps while it is in use. So the whole idea is this one-time permission or while it is in use. So there's while it is in use, and then there's also one-time permission. With the one only this time permission, what happens is that as long as the app is in the foreground, or there is a foreground service that is running which has this permission, the app will have that permission. So you can think of it broadly as, for that session of the user has permission. That permission is granted. The moment the app is going into the background and there are no more foreground services running, the permission is revoked. So the next time the user the app wants that permission, a new pop-up dialog comes up. There is one more thing to note here is deny. You can see on the screen that there's a deny option available, right? The deny, when the user denies this multiple times, that is automatically considered as deny and don't ask. So you need to educate your users about this, and you also need to mitigate for this. There is no explicit entry or a UI which gives an option which says that deny and then deny and don't ask again. Multiple denies will be considered as a deny and don't ask, and then you will have to take the user to the settings and request for that permission all over again, which is a more cumbersome process. So please ensure that you educate your users accordingly, and take into consideration that people understand that multiple denies will lead to the app not being able to request permission again. Now, in terms of permission, there's one more thing that I want to call out. One is a auto reset permissions. The system resets app permissions if you don't use it for months. So a lot of times I mean, if you take your own phones, for instance, and see, there will be apps that you have not used for many months and have been there on the device, and they have permission, all the permissions that you've given earlier. Now, yes, you had a legitimate use case for giving those permissions at that time, but then these apps are sitting there and they have those permissions, and that might lead to sensitive information being leaked. So what happened? What this auto reset permission the feature in Android 11 does is that if you are not using the app for a extended period of time, the permissions are actually revoked automatically by the OS. And that means when when you go back to the app after an extended period, you might need to give the permission back again. This avoids the apps from using these permissions in the background or run in the background, or avoid any illegitimate use case that you might not have envisioned before. The other thing is to note here is this only affects apps that are targeting Android 11. So maybe today, if you're not targeting Android 11, you might not be impacted by this immediately, but in future releases, this will automatically come into picture. There is also a legitimate reason for apps to say that I want to disable this feature, and that is where a new settings has been actually added. Again, this is also my understanding is that there's a policy behind this also. Not every app can go ahead and say that I want to not be reset, the permissions not to be reset for long usage, but for legitimate use cases, you can actually go ahead and do that. So with this, do not assume that permissions that you have already received means that you have it throughout the life cycle of the application. Every time you actually use it, you need to check it. The other thing is there are many instances, there are multiple instances where we've seen a user workflow where the user is onboarding, the permission is asked for it. If the permission is not given, the user exits the user is forced to exit the app. And then subsequent screens after onboarding, where the permission is given, there is subsequent screens, and every time you launch the application again, you directly go into the home page without going through the onboarding. And in the home page, if you're using these permissions, you're not checking whether those permissions were given or not, because you're assuming that by the time you come to the home page, or under any workflow you come to the home page, you have already got the permissions. Those sort of use cases will start breaking, and that is something that you want to take care of. So okay, quickly moving on. Foreground services. We introduced foreground services concept in Android 10. There were things like media projection location, media player, phone call. All these things had foreground. You had to specify the type of the foreground service, so that permission, the permission to use these particular APIs are available for that foreground service. Now in Android 11, we're introducing microphone and camera. So you might, if you have a service, foreground service that is listening to the microphone, or is actually is opening up the camera and want to take data from the camera, you need to kind of ensure that those particular services are marked in the manifest and their foreground services are provided. Foreground service types are provided. This is important. Otherwise, the app, and interesting, and the thing to note here is that in your test cases, you're not looking for a crash here. You're basically looking, if you don't provide these foreground service types to your services, what happens is that the sensors will not send any data. You'll always get null. But the app doesn't crash saying unsupported exception, unsupported operation exception, or anything like that. It will just work as if the sensor is not sending any data to the foreground service. So look for it. Ensure that if you are taking these sensors and using them in foreground services, you are declaring the foreground service types accordingly. Next thing is foreground notifications. This is purely a user change. There is nothing as a developer that you need to know, but just understand that when you're running foreground services earlier, there used to be a running full-time notification which could not be dismissed, non-dismissible notification that was there on the screen. Now you can dismiss that, but rather you can actually minimize it. It goes to a lower pane. So there are three panes. The top pane, then the silent notification, and then you have the foreground services pane. So in the foreground services pane, these will actually go. So if you look at the second image, all the foreground services that you're minimizing from the notification tray to make the notification more manageable will minimize itself and go to the last tray. And if you click on the icon there, it will immediately expand itself to the full notification, so that you can read more information, that is the full information that is presented on that notification. So this is something that a user might actually will see. Just be aware of this change. Now, package visibility. This is something that I'm very sure a lot of the apps will actually be affected with. Now, earlier, if you wanted to kind of share data with another app, or you wanted to understand if another app is installed on the device, the standard mechanism. So if you go to Stack Overflow and say how to find if a particular app is installed on a device, the standard answer would be go to the package manager with the full package name, check whether there is a package like that installed on the device, and you could get that data. Now, with the new package visibility model, unless and until you declare explicitly the package names that you want to request and understand if they are installed or not, you will not get any data from the package manager about them. So it will be like the app might be installed because you haven't shared this information using the queries tag in the manifest. What happens is the package manager will return null, which you can misinterpret or incorrectly interpret as a fact that the app is not installed, but actually the app is there. It's just that you did not have the permission to look for it. This is there in a lot of third-party SDKs also, so that's something that you got to very thoroughly check for, because this was a standard way for a very long time to identify. Classic example: if you want to share something to a WhatsApp application, you first initially check, or to a Pocket application, you initially check whether Pocket or WhatsApp is installed. If it is there, you call the intent and then share the information there. But that check will not work correctly now, primarily from the fact that yeah, so if you don't actually declare it under the queries using the queries, those checks will actually start failing. So it's not just your apps that you need to check, you also need to check the third party libraries that you might be using to ensure that there is this rule does not get broken. There is also one more thing here to understand is that there might be cases where you can actually there are cases where you need a collection of apps. You want to understand for a collection of apps, say that is for a particular intention, like you want to create your own custom share dialog. So you want to know for this data type what all applications are there that I can use, or what all applications can I show in my share dialog. For that, you can actually pass the intent filter in the query. So when you query for with an intent filter, then all the apps that actually can service that intent will be listed back by the package manager. For this, in the queries, in the manifest, you have to declare the intent which you want to ask for. There is also a new permission called as query all packages, and that's for very few use cases where an app needs to understand all the packages installed. Again, this will be controlled by policy. So unless and until you absolutely need this for a use case in your application, don't request for this permission. Tracking private data access. This is a very interesting API, only there in Android 11. This is a new thing introduced, and something I feel most apps should definitely use. This will allow you to understand and rectify potentially unintended data access. So it could be a library that is sending, and we have seen many times here where apps have added a third-party library. And we've seen that without declaring, some of the users' private or personally identifiable information like email and things like that are shared to a third-party server. So according to Google say play developer policy, you're supposed to clearly either encrypt that data or ensure the safety by encrypting, and on top of it you're also supposed to declare to the user that you're actually collecting this data and taking and putting it into your server, in your third-party server. And with no mistake from the developer, because the developer did not understand this was happening in the third-party library, they added it, but their app gets flagged for private data access, and then they get suspended and they have to go through the whole thing of correcting that and resubmitting and all that. So this particular new feature allows you to track all the unexpected data access. There are some features like, okay, I want to track for a particular module and tag certain accesses to a particular module and things like that. You could do it, but it's a very useful thing, and you can clearly understand whether it's coming from your code or it's coming from an SDK that you've added and things like that, to kind of quickly go ahead and rectify all unintended private data access. And this is something I feel legitimately should be done by every app. An audit like this should be there and correct all the problems, and not go into this problem of getting suspended in play for something that you did not know about. So that was some of the privacy changes. I'm just keeping this slide here as a summary. This is for, I'm not going to run through it again. This is basically a list of things that changed, some of the most important things that changed. You guys can take a look at it. This is from our developer.android.com website. And this whole page is there too. Take a look at that. Now, when you look at the new features, one of the most interesting and as a developer, I was most excited about was the app compatibility framework. There were many times that I've seen, where even in my testing, there would be a particular new feature or a change that would break in app's user flow early in the user flow. So unless and until you wrote code and fixed that problem, you are not able to test the rest of the workflow. And that was very cumbersome, because you can't get a tester to go ahead and test everything and tell you the 10 places where things are breaking. You really need a developer to kind of fix problems, and then realize there's this new problem in further down or deeper in the workflow. And that took time for testing, a lot of time in testing. This, with the app compatibility framework, what happens is that, or what the feature is available is that you can go ahead and toggle certain behaviors. Like you are seeing that you have a crash because of scope storage. You can turn off scope storage and test the rest of the features or rest of the use case. So you can actually bypass a particular restriction while you're testing, by toggling them off on the app compatibility framework, and then continue testing to find out other issues. So individually, like you can turn off all the features and then turn on one of their flags and then see where all that particular feature is impacting, or you see that there's a combination of new features which is causing a crash. You could clear off all the other features. You can turn off all the other features and just turn on the 2 or 3 features that is causing the crash and test your apps completely. This legitimately speeds up your understanding of where all the app needs to change. And if you want to temporarily bypass a particular restriction, you can do it with this. One thing to notice, this is only going to be there in developer preview. Signed build, which is basically a build that will go to a user's device, will not have this feature for user to kind of bypass any restrictions on the OS. So don't consider this as telling your users. So this, what I'm trying to say is that your users cannot go on and turn off a restriction on their device so that apps can run bypassing that restriction. This feature is only available in developer preview, and this is only for people to test, only for developers to test. Final builds will not have this, so don't make plans with that. Now, refresh rates. Earlier, you might have seen many ads in which OEMs are advertising multiple refresh rate support, 90 hertz, 120 hertz screen, 60 hertz screen, and things like that. Now, a lot of people consider this to be just clarity of the screen. This has implications on your program. When you're running at 60 hertz, you have the 16.6 milliseconds for your app, for your operations to run with jank free, right? And that is what most of us developers have tuned our application for. When the screen is running at 90 hertz, you have less time because your screen is refreshing at a much higher rate, which means the time between each refresh cycle is shorter. On a 120 hertz screen, it's completely different. But having said that, when you have a screen which can support 60 and 90, for example, you can run the screens at 30 as well as 45 too. And now in Android 11, you can go and request your system to say that I want to run at 30 hertz at this point. This is useful for games and things like that, where there's heavy computation. And if your app is one of those which basically needs a lot more time between refresh cycles so that you don't see janks, and that legitimately needs it, not because you've not optimized it. With all the optimization, you still need more than 60 milliseconds. You can request for a slower refresh rate, and that you can pass that request to the OS. And that is a feature that is actually added both in the SDK level as well as in the NDK level, so that games as well as apps can actually take advantage of this. There is a very interesting article about how refresh rates affect apps. I'll share that towards the end of this deck. Please do take a read of that. That gives you a much better perspective of why a feature like this, which is basically a hardware feature that you might dismiss as a change in the hardware, really how it starts affecting your applications, and how that might then go ahead and affect your app vitals, then affect your rankings and so forth. So you really have like far-reaching implications of not fixing for these changes. Resume on Reboot is another interesting feature. Earlier, when a new OTA, over-the-air update for the OS came, you might have noticed that in the later builds of Android, you will actually have to punch in your you have to log in basically the system by punching in your password or PIN. Then only the system will be able to completely boot up. And you see that, hey, you would see that, and that basically avoids the system to automatically reboot itself to install and things like that. With Android 11, we're taking away that restriction where the system the OTA updates we can run overnight OTA updates, which is when most of the users are connecting to a Wi-Fi network and might be keeping the phone for charging, which is both conditions are kind of the best. That combination is the best time for doing updates which are large. And which have like performance implications. Like OTA updates don't happen when the system is like low on charge. Now if an OTA update happens, apps can function normally after the OTA update. So you're not going to miss a service running and downloading something in the background just because an OTA update automatically restarted the device in the night. And that will lead to a better experience for the user. Now, 5G State API. This is something that does not have a direct implication for us. Basically, if you are developing an application for India, If you're doing something for from a global perspective, where you're also in markets in which there are 5G networks deployed, then this will actually have implications. If you're developing only for India right now, then even though there is 5G enabled devices out there, there isn't a 5G network that actually you can take advantage of and take advantage of and create a differentiated experience for the user. Now, there are two APIs that you want to kind of really look at: is a 5G dynamic meteredness API and the bandwidth estimator API. Both of this are used to actually ensure that users on a 5G network will have a better experience, and at the same time, you take care of not exhausting the users' bandwidth and things like that, or quotas in terms of their data usage. That is something that these APIs will allow you to kind of do better. Call screening is another improvement. Some of the improvements happen. This is not very commonly used, but I want to call it out because few apps are there which are actually like third-party call screening apps. So now there is an extended support. It comes in red. It actually has apps can provide rejection reasons and things like that. So the whole experience is actually a little better when call screening is when you take the call screening use case into consideration. Again, a lot of this is based on feedback that people have shared with us. Wireless EDB, another very interesting and useful feature for developers. There is a new option under developer options where you can actually turn on wireless ADB, which means if you have the device on the same network, you don't need to connect the computer and the wire for debugging. You can go use ADB and run commands on the device wirelessly. This is very useful because you don't really have to kind of have a cable that has the right ports, USB-C to USB-C. Many times we see that when people change their laptops or when people change devices, they then have to find the hubs and adapters to kind of connect for development, and that's a restriction that is removed. This is a convenience feature. In my testing, in my personal testing, it's been a slightly slower installation, very marginally slower in terms of installation. Compared to how much time a build takes, the installation time is negligible. But from a pure technical perspective, yes, a wired connection is slightly faster. But for the convenience that this thing is adding, I feel this is something that I would always opt for. And basically, I've been using it for some time now, and my cable is in the cable. I've never had the need to kind of pull out my cable at any point of time, and all my development and testing is happening, and all the ADB functions are working correctly wirelessly. Screen recording, yes, there is an improved UI for screen recording. There is this new toggles that we have added in the notification. This is because these were the most common use cases that people had to otherwise go into, go into the settings, turn them on, come back, and then toggle them once they finish recording, go back and toggle them. So we've added that to the notification tray. Again, another thing is when the notification is minimized, it is actually in a bright red color, the notification itself, that users are always very quickly are very clearly communicated that recording is happening on the screen. So it's a highly visible red background is used for their notifications. And there were a couple of buttons in the notification. Those are removed because, and those are now removed in your current new UI. So there's a change in the screen recording UI. Notification history is another very interesting feature. This was there. This was a request a lot of people had where when you have a lot of requests, even I have done this mistake of going and saying clear all notifications. And then I realized that, oh, there was a coupon code that I did not write down. Somebody sent me a coupon code, and now I have no way to find out what it is when I'm using the app where I could have saved some money. Things like that. So now if you kind of go ahead and turn on the notification history, bear with me, the screenshot that I'm sharing here is an earlier preview. The final release might be slightly different in look and feel, but you get the gist of it, right? It's basically all the history of a notification, the time it came, and what the notification content was is there in the notification history part of it. So you can even if you swipe out, you can go back into notification history, which can be accessed from the notification tray, and see the old notification that you received. Now there are more APIs that are added to the disallow list right now. So if you would look at it, this is something that I want to kind of talk a little bit on very quickly. Is if you take the last few releases, there's this whole concept about white, gray, black list. We call it disallow list, allow list, and temporarily allow. And basic idea is that there are a lot of private APIs which developers are not developers are. So basically, allow list is a list of all APIs which developers have freedom to use, and any changes to that will be communicated, and behavior of those APIs endpoint APIs are guaranteed by CTS test cases and things like that. Now, there are a lot of non-public APIs or non-public SDKs which are there within Android OS. They are used for maybe testing the OS. There might be some things for OS developers to kind of work with. These APIs are they are needed, but they're not supposed to be supposed to be used by app developers for creating use cases. Many a times, app developers look through source code and figure out some of these APIs and then hack and use them to create hacks and bypass certain behavior in the OS or bypass certain restrictions from the OS and things like that. So now, when this started becoming very rampant, Android team decided to actually create this allow list. Allow list is all the APIs that an app developer can use. Disallow list, which is basically a list of APIs that you are not supposed to use, and if you use the return type is going to the return would be null or not supported operation exception or things like that. And this is to discourage developers from actually using the non-public SDKs or non-public APIs. And there's other thing that you might want to see. Sometimes on certain devices it will work for certain builds, but there is no guarantee that those APIs will not change with an update. There's no guarantee that that API will be there in the next version. So we don't really give any documentation or updates to third-party developers that a particular something that is there in the disallow list is changing. Anything in the allow list is always communicated in change logs, and in using our marketing channels, we communicate the changes. But disallow list, we never communicate. Now there is this temporarily allow list, which is earlier called as gray list. The temporary allow list is basically a set of APIs that you shouldn't be using, but for this is like a transition period where even if you're using, it will continue to work as expected, but what we are suggesting is you go ahead and change this. You can actually figure out these usage of non-public SDKs by turning on this strict mode. There is a flag there that you can enable, and it will actually list out and you can say what behavior you want to crash, or you want to kind of get warned, or you want the app to kind of stop when a non-public SDK is getting used. This is not a very simple or quick change. A lot of your non-public SDKs might have an alternative. And a lot of times people are not aware of being aware of the fact that it's a non-public SDK, so they continue to use it. Once they are aware that, oh, this is not supposed to be used, they change to the more public and right API under the allow list. But there are cases where third-party SDKs work around certain restrictions. And then if it's a third-party SDK that is doing it, it is not easy for you to change it. You will have to work with the SDK provider, and the SDK provider has to provide you an update with a new version that is using the right APIs. So that might take time. That is why this gray list or temporarily allow list is there, giving developers time to make those changes. If and with every release, we are moving more of the things in the gray to black, which is basically temporary allow to disallow list. We are completely moving it to the disallow list. And even in Android 11, there's a lot of things that were temporarily allowed in Android 10 that have become that is disallowed in 11. So you want to kind of check whether any of those changes are there near. Lastly, the last few slides that I have here, we're going to talk about the process exit stat. In Android 11, there's a circular buffer that stores application exit information. So this will tell when an app exits, information related to the exit is stored on this buffer. So next time you actually go and launch your app, you can actually go and get that data, and you can sometimes get a better understanding of why the app exited, which if it is not captured by your the exception is not captured by your crash reporting system more effectively, the information in the exit buffer will allow you to get more data around how to understand that change and then correct that problem. So this is some code that is there on the screen that you can use in order to get that. If your app is targeting 11, the permissions are a little more fine-grained. So what happens is earlier, the two things that you're seeing, the call states and phone numbers were one permission. Now, reading phone state and reading phone numbers are completely are two different permissions. So they are more fine-grained. So if you have cases like this, look through the changes in the permissions and clearly request for the right permission to access the APIs under that. So some of this certain applications might need to kind of change, add these permissions and check. And lastly, important conversations. From an important conversations perspective, now you can actually pin a particular conversation to be important, which means that you can actually say that, so this person in my WhatsApp chat is more important, so show me that all the time. So that person's the notification will not say that WhatsApp has this many or rather, if you have 10 groups in WhatsApp and all of them are chatting with each other, then you will only see the summary of as one icon, WhatsApp, this many chat, and then you have to expand and then understand in each one. Now, if you go into a do not disturb mode, the entire app can be controlled before. Now, per conversation, you can actually do that. This is very useful because you can actually make certain conversations really important and mute certain other conversations which are less important and give them a different behavior under don't disturb and things like that. You can have a bubble for the more important, if the UI supports it, or if the app supports it, you can have a bubble for the new or rather more important conversation and have quick access to the important conversations. So quickly wrapping up, like I mentioned at the start, this is not the only set of features that are there in Android 11. There are many user-facing features as well as API changes that are there. I am only trying to give you a sense of I'm sorry, I'm only trying to give you a sense of the main features here. All of these, I've just touched upon them. My suggestion is go back and understand them in more detail. Their details are provided on our website. There's also an 11 weeks of Android series where we have explained a lot of these things in detail, each one of them with a 10-minute video sort of a model. And that is another set of videos that I would encourage you guys to go and look at and understand things in more detail. The intention for me taking this session was to give you a flavor of the areas that changed and some of the changes so that you have an understanding of what to look out for and what you might want to kind of go ahead and change in your applications. Like I said, the timelines, we are close to we are more in the stability phase, so this is a good time to go ahead and update your apps if there are changes that you recognize, because when the final release happens, your apps should work as expected on the new platform, and nothing and everything should work as it is before. Users should not have a bad experience on a new platform. And that's it from me today. If there are questions, I can take some of them. That's my Twitter handle. So if you think this through and then you find another, you come up with a new question, please feel free to ask me on Twitter. I will answer it there. I usually post a lot of the Android stuff and a lot of these API features and Android tips there. So feel free to follow and ask questions there. Yeah, that's it from me today. Thank you.
Thank you, Amrit. It was such a wonderful session and you did wonderful walkthrough about the Android 11 features. I think the more interesting was the latest features was backward compatibility, which gives very good control to the testers and developers. So yeah, we have a couple of questions. Let's take it.
Sure. What is the ideal time frame after which an auto reset permission will be invoked? So the current one is a few months. That can change. Like I said, uh, a lot of this is fine tuned during this whole developer preview and beta phases. But my suggestion to you is don't keep it like a time frame based model. My suggestion would be every time you're actually do not assume in your code that you have the permission already. Always check whether you have the permission. If not, request for the permission workflow and go through that before accessing any of the functions.
I think that is one of the questions we had. Everyone is saying that awesome session. They have enjoyed your sessions. I hope the session, the valuable insights you shared with us will be helpful for the audience. Thank you for joining us today and make this evening such wonderful. Thank you so much.
Thanks for the opportunity, and I really want to thank the organizers for putting something up like this together, so that more developers are actually aware of this, and it gives a platform for understanding these changes quickly. Gives us a platform to kind of share all these changes and help developers kind of upskill very quickly. Thanks to all the organizers for that.
Thank you so much. If you have any questions, you can directly tag to him at Twitter handle at @amsanjeev. I hope we can take some questions offline as well. Thank you so much. Thank you so much for making this evening so special. Bye-bye.